In this video, we're going to continue our exploration of various behaviors. More specifically, we're going to be creating the avoid behavior. Now, mathematically, avoid is simply the inverse of seek. Really, you can just take the actor and the target used in a seek operation, flip those around, and you'll have a scenario where the given actor will run away from the target instead of towards the target. Now, in order to make this make sense visually on screen, we're going to create a compound behavior. In addition to simply running away from something, we're going to give an effect radius so that the behavior only applies if the two actors are within a specific distance. The reason we're doing this is it gives a much nicer visual effect, since if everything was avoiding based on the entire screen, you just have a kind of general away motion rather than a noticeable radius of effect. So what we're going to do is go back to our behavior classes, and then after our behavior seek, we'll define a new behavior class. This will be class behavior avoid. It will extend behavior. We can drop in the braces for the class body. Now there are two different things we need to remember inside of the behavior avoid. Just like with behavior seek, we need to have a target. Basically, inside of avoid, we need to know who it is we're avoiding. In addition to that, we're also going to store a radius. So we're only going to worry about avoiding the target if we're within a specific distance to that target. So the fields are going to be an actor for target and a float for radius. Now we're going to need to set these fields up inside of our constructor. So let's put the public constructor together as public behavior avoid, beginning with the float for our weight. Then we'll need the actor target, and finally the value for radius. So we'll have a float parameter called radius. We'll make sure that we get our chained call to the base constructor. So we'll pass in weight. Then we'll drop in the constructor body, and we can initialize the two fields. This dot target being set to the parameter target, and this dot radius being set to the parameter radius. Alright, that's all we need to do inside of the constructor. So now we can turn our attention to update. We will override update and remove the call to base.update. Now we can put together the math necessary for doing our avoid operation. Just as we had done inside of seek, we're going to create a target direction based on our target's and actor's position. So we will make a vector2 variable called target direction. And let me change the capitalization of the D on direction. Then that direction vector will be set to the opposite calculation we'd used in seek, where in seek we subtracted the actor's position from the target's position. Here we're going to subtract the target's position from the actor's position. So actor.position minus target.position. So we have a vector that is pointing away from the target. Now, just as we had done before, we're going to need to normalize this in order to use it with the actor, but before we normalize it, we can now take advantage of the fact that this vector2 is also containing the distance between these two objects, because that distance now comes into play since we are only going to affect the actor if we are within the value specified as radius. So we can do a check and say if target direction dot length is less than radius, meaning these two actors are within the specified radius from each other, then we'll go ahead and perform the necessary direction adjustment on the actor itself. Again, before we apply that direction, we do need to take our target direction and normalize it. Then we can take our actor, modify its direction, so actor.direction plus equals target direction times this dot weight. Alright, that takes care of our setup here. looking at, let's see, same variable, the start radius. I'm very briefly just going over our constructor since IntelliSense seems a little bit unhappy. Let me build first, though. Let me make sure that if we build the float radius, and I've got some spelling on radius. As a matter of fact, going all the way back to the field, there's a spelling error on the field itself. I need to swap the U and the I on radius, and propagate that down here to this dot radius. Grab our float radius, drop that in. Now if we build, we have one last instance that we had changed. Let's get that up to date with the new spelling. Build, no more errors. All right, and that takes care of that. So with some minor spelling out of the way, now we have our avoid behavior in place and ready to go. Let's jump over to the game class, and let's set up a scenario that will use behavior avoid. Let's jump all the way to the top, near the top, right before we create the leader actor. Let's make an actor called an obstacle. So an actor variable, we'll call this variable obstacle. This will be equal to a new instance of actor. We need to feed in the arrow texture for texture. And for the color, let's specify a new color with the values of 255 in red, 200 in green, and 96 in blue. Then we can finish off the call to our new actor. Now with this new obstacle, we can take our obstacle and let's position it somewhere specifically on screen. We'll say obstacle.position will be equal to a new vector 2 with a value of 400 by 300. Given our current screen resolution of 800 by 600, this should place the obstacle in the center of the screen. Now let's go into our individual drones. So here at the bottom we have our drone creation loop, and let's set each of our drones to avoid the obstacle actor. So we can say drone.behaviorList.add. We'll add a new behavior avoid, and we can drop in a weight of 0.2, a target of obstacle, and a radius of 80. So that means we'll wait till we get within 80 units of the obstacle before we begin avoiding. We need one more parenthesis to close off the call to behaviorList.add. Now that we have this behavior registered with each of our drones, we should be ready to jump in and test. So now if we begin running around, let's take control of the leader actor so that we can follow the swarm and have the swarm cross that obstacle actor. And you'll notice every time the drones get close to the obstacle, they try to move away from it to avoid it. But because of the layering in place, they're still trying to seek. So now they run into a scenario where they're smoothly seeking until they hit that obstacle, then they rather quickly try to jump away from it to avoid it. So now I've got 3 things layered onto each of our drones. They're all trying to seek and follow the leader. They all have a bit of random variance applied through a behavior of wandering. And every time they hit the obstacle actor, they try to avoid it. And so you can see the entire flock of following actors kind of split and go around the obstacle. So let's set up a slightly more complex scenario. This works well in the case where we have a single obstacle. Let's see what we would need to do if we wanted multiple obstacles. Let's scroll all the way back up to the top, and let's change the way we're defining obstacles. As a matter of fact, let's create a list to allow us to manage multiple obstacles. We'll make a new list of type actor, and we will call this list obstacles. Then we'll turn around and instantiate the list, new list of actor. Now we also need to carry this color value and apply it to all of the obstacles. So I'm going to make a color variable called obstacle color and set that to be equal to the value we had specified for that yellowish obstacle color. Matter of fact, I'm just going to cut the new color with the given values and put that into place right after obstacle color. Now we no longer need the individual creation. As a matter of fact, we no longer need the individual obstacle variable So we're actually going to pull the entire definition out. So instead we have an obstacles list, an obstacle color. Now we want to create a handful of obstacles. Now to handle the creation, we'll use a for loop. So we'll assemble a for loop. We'll use this loop to create 4 actors, and inside of the loop, we will add new actors to the obstacles list. So we can say obstacles.add new actor, specify the arrow texture for the texture parameter, and the obstacle color for the color parameter. This is the only statement we need to apply here inside of the for loop, so we'll remove the braces. And we also have a missing parenthesis on our add call, so let's take care of that and make sure that everything is finished here inside of the call. Alright, this will take care of making 4 obstacles, but we still have to worry about their positions. And I've got some specific positions in mind, so rather than using a random position for each of these, we're going to go through the obstacles one by one and set specific positions. Now that they're inside of the list, if we know that we simply want objects 1, 2, 3, and 4, we can simply grab them by element out of the list. So that means we can look into the obstacles list, grab obstacles sub 0, and set its position. So that position will be equal to a new vector 2, and for the first object we'll give a pixel value of 250 in X and 200 in Y. Now we have 3 more obstacles that we need to set up positions for. So we'll copy this line, paste it 3 additional times, then we can address obstacles sub 1, sub 2, and sub 3. Alright, for the second obstacle, obstacles sub 1, we'll set a positional value of 530 in X and 200 in Y. For obstacle sub 2, we'll set a position of 250 in X and 400 in Y. And finally, for obstacles sub 3, we'll set a position of 530 in X and 400 in Y. Alright, with all of our obstacles created, we still have a problem in our drone behavior list defining. We were using that obstacle variable that no longer exists. Also, in addition to the single line, we also need a way of having these drones avoid all of the obstacles, because each behavior avoid instance is going to cause the actor to avoid exactly one obstacle. Here we need to be able to avoid multiple obstacles, so we will assemble a loop that will create an avoid behavior for each obstacle. So what we'll do is we'll assemble a for each loop, and we will loop through all of our obstacles. So we'll name the local variable here obstacle, and the collection that we're interested in is the obstacles list. Now, since this loop is creating a local variable called obstacle, we can simply take our existing line where we're adding the avoid behavior to the drone and paste that inside the loop. And that will take care of now having an obstacle variable in scope and applying an avoid behavior to that obstacle. Alright, now that we have all of our assignment fully corrected, we should be able to test and run the game. So now you can see right off the bat we have 4 obstacles, and if we lead the following actors across all of those obstacles, you can see that they avoid all 4 of them. Every time any of the drone actors get within the 80 unit radius of any of those obstacles, they all try to turn and avoid that obstacle. So one last thing we can do, if we let the simulation go back into automatic mode by letting go of the controller, we can see that the leader node will happily cross the obstacles. In order to finish the idea that each of these things has a life of its own, let's cause the leader actor to avoid obstacles as well. So we'll go outside of the drone creation loop and create an additional for each loop. So we can say for each obstacle in obstacles, we want to add a behavior avoid to the leader. So leader.behaviorList.add new behavior avoid. We'll pass in a weight of 0.2. We'll give a target of the current obstacle to avoid and a radius of 80. We can close off the call to add, and that should take care of our leader avoiding all obstacles. Let's jump into the game now and test things out. Now watch the leader. I'll have to leave the leader on automatic since the gamepad control has heavy enough weight that I can still force the leader to cross obstacles. But if we watch every so often, the leader will encounter an obstacle and turn to avoid it. Now again, I could take control of the leader and lead him almost directly across. Granted, it is a little bit difficult because you can kind of see the leader still wanting to edge away even though I'm trying to control it directly towards an obstacle. So even with the heavy controller input, you can still see the layered behavior through all of the behaviors. So with this now, one last thing to point out is the fact that unlike with the seek behavior, we're not sharing avoid behaviors between any specific actor. In this case, the reason I wanted to have separate behaviors was so that the leader's behavior could be configured separately, even though for the purposes of this example we're using the same values as the drone avoidance. Having separate behaviors between the two allows us to tweak them individually. Now, of course, depending on your own scene, you can set this up at any number of layers. You could have a single behavior. I guess you could have a single behavior per obstacle, and then apply the same avoidance behaviors to all the other actors. But again, since it's just a matter of a specific behavior applying direction to a specific actor, in the case of avoidance based on another actor, it's just those three things that have to combine: target, actor, and a weighting. So with that has multiple obstacles in effect inside of our scene with both of the drones and the leader avoiding the obstacles. So that is going to wrap up this video.